Bismillahirrahmanirrahim. Greetings. This is going to be a preliminary lecture for 2 or 3 more lectures to come about distance, displacement, velocity, speed, and acceleration. Now, like my other lectures in my channel, I'm going to present this at a freshman college level student, and a senior high school student can also benefit from them. I'm uploading all my lectures for the benefit of the public, and I hope they are beneficial. Now, in the comment section, please share with me your comment and your suggestion, because that will have a positive effect on my effectiveness as a teacher, because there is always room for teaching enhancement. And also, if you have any topic that you wish me to give lecture about, please indicate that in the comment section, and if I may notice it, I will prepare myself for such a lecture. Okay, then let's get started for today's preliminary lecture. A swimmer swims the length of a swimming pool and returns to the same place that he initially dived in, let's say, 20 seconds. Now, if the length of the swimming pool is 30 meters long, now the question is, what is the average velocity of that swimmer round trip? Do you follow me? Now, you may have already the answer quickly in your head, or if you don't, please pause and with a pen and paper and give the answer, then start again and share your answer with my answer. Now, let's see what will be the scenario. The swimmer swims 30 meters one direction and 30 meters back, that's 60 meters. And we are always used to it, and we have heard it most of the time, that velocity is distance divided by time. The distance round trip is 60 meters, and the time round trip is 20 seconds, so the average velocity should be 3 meters per second. If that is your answer, I'm afraid to say your answer is not correct. Now, what will be the correct answer? We are going to investigate, and we start with the subject of vector. What is vector? Now, whenever we deal with vector in all our life, every day, when you pull something or you push something to relocate that one, certain direction you want to move it, you are dealing with vector. When you are walking, you are dealing with vector. Just walking, you are dealing with vector because you are going certain direction and some kind of magnitude you are going to. So then, let's see what an experiment that can motivate for us to make a formal mathematical definition for the vector. Now, suppose that you have an object and you are trying to pull or push it. Let's say pull it with a piece of a string or piece of rope. Now, when you are pulling, the direction you have in mind, what direction you want the object to move, to relocate, so you're pulling the string with certain angle. So the angle is involved. Is that right? I'll come back to that. And when you pull that object, you're putting some kind of stretch on the string, on the rope. And that stretch that you put on the tension that you put on the rope or a string, that tension can be calculated. There are devices that can tell us what that is, and they are calibrated by Newton, unit of Newton. They are scaled for that. So based on this just simple demonstration, simple experiment, daily experiment, we can go ahead and define what a vector is, mathematical definition. So vector is a mathematical entity that has both direction and magnitude. I repeat myself, direction and magnitude. They are mostly represented in a plane by a line segment that has initial point that usually a dot represents that, and a tip or final terminal point that usually the arrowhead represents that. And the length of that line segment represents the magnitude of that vector. And it's also again scaled and calibrated. So this is what we are dealing. Now then we go to vector space. A space of vectors is a set of vectors, naturally non-empty set, consists of all the vectors in the universe, and the two operations are involved in there. One of them is addition of vector. The other one is a scalar multiplication. We said that the set is closed under addition. That means if you take any two vectors from that set, you add them together, that we are going to investigate how we add two vectors, the result will be another vector. And also it's closed under a scalar multiplication, meaning if you multiply a vector by a scalar, that I'm going to come shortly and say what the scalar means, the result will be in that set. All right? Now, let's see what a scalar is and what does a scalar multiplication mean. A scalar is a number. As a matter of fact, in this lecture and the lectures to come, we are dealing with real numbers, positive, zero, negative. But it can be complex and it can be other kind of numbers. Now, a scalar, why is it called a scalar? Because when you hear the word a scalar, you know you are talking about a vector space, which means the number that you are multiplying, that number is being multiplied by a vector. Do you follow me? That is one advantage. And second advantage is just the literal meaning of the word scale. It will scale, when we multiply by a number, it will scale the vector. The length of the vector will be scaled according to that multiple number. That's what the word scalar multiple is adapted, rather than saying number multiple, real number multiple. Okay, now 4 different planes we discuss about vector. So vector is in a plane. It's in a plane. One of them is regular plane, the plane that we are familiar and we do a lot of geometry in our high school. The second one is a Euclidean plane. And because we are dealing with length and point, and then later we talk about angle and parallel vectors, what they mean. So in reality we are talking about Euclidean plane, because we are applying Euclidean postulates. But in regular plane, we don't have any postulate to talk about. So that is the second plane we apply. The third one that we discuss about vectors is in a coordinate plane. And coordinate plane, you are all familiar consists of 4 quadrants. That is that 2 axes, vertical and horizontal axes, they are known as x and y axis. Horizontal is x and vertical is y. That divide the whole entire plane into 4 quadrants. And every single point in that plane in coordinate system has a unique location and unique address. That is not the case with vectors. In all 4 vectors, the fourth one I'm going to mention what it is, the vectors are loose and subject to motion. We can move it around. As long as we preserve the direction and the magnitude of the vector. All right? Now the 4th plane that we also discuss about vectors is the complex plane. A complex plane is a Cartesian plane, coordinate plane, but the y-axis, the vertical axis, is designated as an imaginary axis. There's nothing really imaginary about that, but that name has been stuck with that. So we do also investigate about vectors in that plane. So 4 different planes we are going to discuss about the vectors. Now, 2 vectors are equal if they have same magnitude and they have same direction. And what other thing we know is that 2 vectors are let's say opposite one another, but they are parallel but opposite. They have same magnitude and same but different direction, parallel in the sense. Some books they call it anti-parallel, but you can say parallel but in opposite direction. That's another 2 vectors. Now the other one is that a scalar multiplication, let's talk about. And a scalar multiplication, a scale is a number, therefore we are going to discuss about vector that geometrically, again I repeat myself, is designated by a line segment. So when we multiply geometrically and pictorially, when we multiply by a number positive between 0 and 1, that will cause the vector, the length of it, geometrical representation, the line segment to shrink. By what? By the factor of that scalar. And if you are multiplying by a number bigger than 1, that will make the vector longer with the same direction by the factor of the scalar. You follow me so far? 1 is trivial. I come back to 0. Now, exactly same thing is with negative. Exactly. The only difference is that when you multiply a vector by a negative number, everything stays the same, only direction change. The magnitude is the same, direction change. Do you follow me? That is when you multiply by negative. So again, negative between 0 and 1, between negative 1 and 0 will cause it shrink, but opposite direction. And numbers less than to the left of negative 1, it will make it to longer, stretch that one, preserving the direction by that factor. We can think about the absolute value multiplying. And then going back to 0. 0 vector is that the magnitude of that is 0, but when we multiply a 0 by a vector, you do not get 0. Because 0 is a number. You are multiplying 0 by a vector, so you are in vector space. So you are talking about vector. So that is called a 0 vector, and that is the only vector in the vector space that does have magnitude, which is 0, but no defined direction. So there is no direction imposed on that or applied to that. Does not have any direction. So now if we talk about the two parallel vectors, now let's talk about addition of vectors. Now when we add two vectors, always remember that we add head to tail. Never head to head or tail to tail. So suppose that these two are vectors. This is direction going that way, and this is direction of this vector going this way. So we want to add them together. So the head of this will be added to the tail of this one, and then from the tail of this to the head of this one will be the result of the vector that we are interested in. So for example, if I can demonstrate that one, this the pen that I have in my left hand will be what? Will be the result of the addition of these two vectors. And when we multiply a vector by a negative, the same vector by -1, same vector but the direction change. You see that? The direction change. Now, you put them tail to head and you end up with what? Look at that, you end up with 0. So that gives the answer of us that the swimmer swimming, going and coming back, its velocity is not 3 meters per second, its velocity is 0. Why? Because velocity is a vector. Now why velocity is a vector, that's another interesting subject to discuss, and how many advantage we receive for discussing about velocity as a vector, and how much advantage it has to the word of speed, which is really the magnitude of that. We will see that in the coming lectures. All right. Now I think we know enough about this one. Now let me stay out of way and repeat the same thing I have said, but pictorially representing them. Let me do that if I may. Sorry, I don't have a whiteboard or blackboard so that I can lecture and do them there, so I've done them to prepare them ahead. Okay. Now, here is what I started. You see, we are pulling the object. The tension that we are putting on the rope is what? Is the force. And there are devices, apparatus that we can measure that one. Then this will be a geometrical representation of this scenario, and that is a line segment that has an initial point that usually denoted by a dot, and the terminal point that is usually designated by arrow. So this is a geometrical representation of a vector in a plane. Now, second we go to a scalar multiplication. So I have already demonstrated that verbally, but let's see that one in also application and what that means. Now here, let me cover this one and go over this one. Now, you are multiplying a scalar by a vector. A vector usually are shown by an arrowhead. Now, if the scalar is a number between 0 and 1, for example, I selected half. Now, the length of this vector, as you notice, when I multiply by half, it becomes the same vector, a vector with the same direction, but the magnitude of that into half. As you notice, the length of this red color, arrow is half of this one. You follow me? And if A, the scalar is bigger than 1, let's say is 2 in this case. Now if this is our original vector A, when I multiply by a number, let's say a scalar is 2, the result, which is this red vector, has the same direction as this one, but the magnitude of that, which is the length of that, is twice this one. And the very same is going to go for negative. The only difference is that the direction change when we multiply by a negative number. That's the only difference. Now, let's talk about adding vectors geometrically and pictorially. Now, suppose this vector, one person is pulling this object, let's say northeast, and the other one, look at that one, is southeast, is that right? Is pulling, and with the same force. From our daily experience, we know that exactly this object is going to move horizontal line. And the force that is going there is less than the addition of these two, but larger than either of the two. So the geometrical interpretation of that will be this one. You see that when we add them, we add always head to tail. So the head of that is added to the tail of this, and this red here is the addition of A and B. Right now we don't need these two anymore. We don't need them. They came there to help us to find A plus B. And that is the A plus B. Now, if the two forces that we are applying, they are not of the same magnitude, then the one that is larger magnitude will win the direction. Now somebody is pulling that way, somebody is pulling that way. When we put them in the addition of vectors, which is head to tail, this is A, and this is what? This is my B. And I add them, this will be my A plus B. And this is the direction the object is going to move. Exactly happens in a real life experiment. Okay, now let me see about adding, subtracting two vectors. Subtraction of two vectors is like subtraction of two numbers. Like 2 minus 3 is same as 2 plus minus 3. That's exactly what we do in vectors. So when we want to subtract vectors, the one that we want to subtract from the other one, so we multiply that one by negative, which means the direction of that will change. And after the direction of that change, then we add head to tail for the addition. Now suppose this is my vector A and this is my vector B. All right? Then when we multiply by negative 1, this vector B becomes this, the direction change. But the magnitude stays same, the direction change parallel to that. In that sense, I mean, the direction change, they are parallel. So how do we add them? We add, if we want to add A plus minus B, is same as A plus minus B. So we are adding this vector to this red color vector, head to tail. When we do that, the result will be the difference of A and B, the difference of A and B, because we multiply B by a negative to get what? To get negative B. And I have it here. And I have it here. So this is my vector A, and that is B negative. B multiplied by negative, B negative. Now look what happens. I put the tail of the A to the head of the B, of the negative B, excuse me. And this will be what? This will be the result of A minus B. Now if I do the other way around, if I put the tail of this one to the head of the A, you notice that this will be A minus B, and this is same vector as this one. As you can see, the magnitude are same, the lengths of the both are same, and they're parallel, and they have same direction. And vectors are loose, can move any place, they don't have any unique places to discuss about. Okay then, do I have anything else? Not for this lecture, but for the coming lectures, we will be talking about the displacement and the velocity, and why velocity, so many advantages we receive for velocity being a vector. Okay, then let me zoom it back and say a few words. Okay then, as always, I thank you for watching. I hope that my channel and my videos are beneficially. I'm doing that for the benefit of the public. And please, I request you, as I mentioned in the beginning of the tape, that share with me your suggestion, because there is always room for teaching enhancement. Okay, then for the second or third time, I thank you for watching. I wish you all happy and prosperity, and please stay and remain safe. So long.